Hello dear friends, this is Devashish and I welcome you all to my channel Statistics Curiosity. Friends, today we will discuss about the Bernoulli trials. And we will see how a simple experiment, that is Bernoulli trial, is used to create several probability distributions and are the basis of some of the most powerful probability distributions ever studied in probability and statistics. Okay, so let's get started. So first we will see what Bernoulli trial is. So a Bernoulli trial has only two possible outcomes. These two possible outcomes are generally termed as success or failure. So and success should be with probability P and failure should is assigned with probability Q. And P plus Q must be obviously 1. Okay. Since there are only two possible outcomes, so sum of probability should be 1 for any experiment. And Bernoulli trial is kind of an experiment having two outcomes only. And for instance, we are playing one game, let's say cricket, and we are ignoring the third possibility of drawing a match, I mean a draw in a match. So let's ignore that. So we are having only two possible possibilities, either a win or a lose. Okay. So winning is, let's call it a success, and losing a match, let's call it a failure. So success will be with probability P and failure will be with probability Q. Okay. And you can also have other examples. For example, an item might be either defective, okay, or non-defective. Okay. So if defectiveness is considered a success, so defectiveness will be with probability P and non-defectiveness will be with probability Q. And obviously you can have multiple items, you might play multiple games, so there might be multiple Bernoulli trials. Okay. So this nature of Bernoulli trial is basically is responsible for creating several probability distributions. Okay. So we will study some important probability distributions arising from these Bernoulli trials one by one. So the first one is Bernoulli distribution. Okay, in a Bernoulli distribution, we are having just one Bernoulli trial. Okay, single trial. Okay, if we observe just one game or just one item. Okay, so if we are playing just one game, so either there will be a win or a lose. Okay, as we have seen in Bernoulli trials definition. So we have just put numerical values. So for we have considered 1 for success, numeric value 1, and 0 for failure. Okay. So x or our random variable is basically is whether the number of success. So if we are having only just one trial, so there will be either one success or zero success only. There will be only two possible cases. So for one success, the probability is P, and for zero success, the probability is Q. Zero success means failure. Okay. So the probability mass function for Bernoulli distribution is p raised to the power x, q raised to the power 1 minus x. If we substitute x equals to 0 in this probability mass function, so it will be p raised to the power 0, q raised to the power 1 minus 0. It will be p raised to the power 0, q raised to the power 1 minus 0. It will obviously give you q. So for x equals to 0, probability x equals to 0 is q. And similarly, if we substitute x equals to 1 over here, so we will get probability x equals to 1 as p. So Bernoulli distribution is a distribution which basically model single Bernoulli trial. Okay. So if we are just having single question, did the team win the game or not? So to model such situation, we are having only Bernoulli distribution. Okay, so this is the simplest one out of all distributions arising from Bernoulli trials. So now let's move forward to the binomial distribution. The second one is binomial distribution. A binomial distribution is the most important distribution of all time. It is the most important distribution arising from basically arising from your Bernoulli trials. It is the most important distribution and is widely used in discrete scenarios. It is widely used. Okay, it is widely used. Okay, so now if we repeat the game n times, that means if we are having different number of trials or a fixed number of trials, if we are having a fixed number of trial, whenever I say trial means Bernoulli trial. So if we are having several fixed number of Bernoulli trials, for example, we are having number of games, 10 matches. Okay. So if we are playing 10 different matches, so 10 is a fixed number of trials. So here n is equals to 10, and we are interested to study how many games will be a success, or we are counting the number of wins out of these 10 matches, or out of n different matches we are counting how many times we won the match or the team won the match. So such situation we are having fixed number of Bernoulli trials, and we are interested in studying how many successes we are observing out of n different fixed number of trials. Okay, so out of n different fixed number of trials, we are modeling how many successes we are having. So in such situation, we call the distribution as binomial distribution. Okay, you are understanding? So in binomial distribution, basically the probability mass function we have is ncx, or n choose x, p raised to the power x, q raised to the power n minus x. So p is the probability of success, q is the probability of failure. So n choose x means total, out of total fixed n trials, we are having x successes. So let's call 10 matches, and we want to find the probability to get two fixed winnings. So and we want to basically we are interested in understanding, in finding the probability that the team will win two matches out of 10. So this probability will be 10c2 and p raised to the power 2. What is small p? P is the probability of success in single trial. What is P? P is the probability of success in single trial. So let's call our Indian cricket team is playing the game, and the probability of success in single trial is, let's say, 0.95%. Sorry, 0.95 or 95%. So the value of P will be 0.95, and 0.95 raised to the power x means raised to the power 2, and Q is nothing but 1 minus P. So it will be 0.05, the probability of losing a match in a single trial. Okay, so it is 0.05. So 10 minus 2 is 8. So in this way you can compute the probability of getting exactly a fixed number of success out of total n trials. Okay, now you are getting, this is called binomial distribution. So a binomial distribution, it counts the number of wins, and the probability mass function of binomial distribution is ncx, p raised to the power x, q raised to the power n minus x. And it is obvious that x might be 0 to n. A team might win 0 matches or 1 matches, or all the matches. Okay, so this is a general introduction for binomial distribution. It is widely used. One more example I should give you. Let's we are testing 15 shoes. Okay, we are testing 15 shoes. So out of these 15 shoes, and we want to check whether three shoes are defective or not. Exactly three shoes or more than three shoes. But out of 15, we want to know whether a fixed number of shoes are defective or not. So in such scenarios, you can, or all the 15 shoes are defective or not, or zero shoes will be defective. None of the shoe will be defective out of these 15. In such cases, you will use binomial distribution. So, okay. So now come to the next distribution. The next distribution is geometric distribution. The third one is your geometric distribution. So what is a geometric distribution? So if we keep playing games until the first win. So domestic in geometric distribution, the random variable is actually the number of trials, required to get the first success. Number of trials required to get the first success. What will happen? Let's say we have played one game. Let's say we have played one game, okay, and we lose this game. So we are losing with probability p, and then in second trial we won the match. So it will be QP. Let's say we won the match in our first game, so the probability will be P. And we are winning the match in our second game, it is QP. And we are winning the match our third game, so it is Q into P, that is Q square P. And in a third in this way we are having multiple games q into it is q raised to the power 0 into p, it is q raised to the power 1 into p, it is q raised to the power 2 into p. So in this way we are having q raised to the power x minus 1 multiply p. Okay, so x is the number of trials required to get the first success. So if we are having x number of x is the number of trials required to get first success, so definitely x minus 1 in x minus 1 trial we will lose the match. Okay, and then at xth trial we will win the match. Okay, so let's understand one example. We are playing let's say we are playing 10 matches, and we won the match at 10th place. So we will lose at 9 different places, and then at 10th place we will win the match. Okay, so at 10th place we will win the match. So it will be q raised to the power 9 multiply p. So in this way we are having the probability mass function for our geometric distribution. So the probability mass function of geometric distribution is q raised to the power x minus 1 into p. So let's understand one more example. Um, let's understand we are having different examinations. Okay, so in first example we fail the exam. We fail the exam, and then we pass the exam. Uh, in one another experiment, in other examinations we fail two different exams, and then we pass the exam. So if we are interested in understanding that we will the first exam that we will pass will be our third exam, or in other words at third place we will pass the exam. We will pass our first exam at third place. So at two different places we will lose the exam, and at third place we will pass the exam. So in this way you are having this AUQ raised to the power x minus 1p, and obviously the x will be from 1, x will start from 1 2 and it will go to infinity. A person might get a win. I don't We don't know na where it is heading, at which place the person will going to get his or her first success. So we don't know. So in this way it is starting from 1 and it is going towards infinity. So these were three important important probability distributions that that were obtained from Bernoulli trials. Okay, so at last I have a surprise question. So mm, so let's understand a scenario where we are interested in understanding in several different matches. We are interested in understanding um, whether where when we will get sorry uh, when we will get our our when we will get our let's say fourth success. So we are interested when we will get in understanding when we will get our fourth success. So we are interested in understanding the probability of having fourth success, a fixed number of success, rth success. It is not four, it is rth success. Okay, so at fourth success or rth success, let's call it. So in this way, we will design a all new probability distribution, which is basically understanding the probability of getting a fixed rth success. You are getting what I am saying? For first success, if we are interested in understanding first success, so the distribution is geometric. Okay, and if we are interested in understanding out of n, a fixed x number of successes. Let's say we are playing 15 different matches, and we are understanding to find the probability. We are interested in finding the probability of getting exactly 8 successes out of 15. Then the probability distribution is binomial distribution. And if we are playing only one match or a single trial, then it is Bernoulli distribution. Okay, but what if we are interested in understanding rth success? It means you might have r minus 1 different successes previously, but you are interested in understanding what is the probability of getting rth success. What are the probabilities of getting rth success? So tell me in comment sections what probability distribution we are talking about, and tell me whether I should create separate video in this probability distribution about this probability distribution. Okay, thank you for watching.